Hello, welcome to everyone in this video. This is the lecture number 3 of digital electronics for semester 6 of BSc physics honors. We already discussed two parts, and in this part we want to discuss digital circuit. Within that, this portion we want to cover up, that is the difference between analog and digital circuit, introduction of switching algebra or Boolean algebra, then Huntington's postulates, then the combinational logic, then truth table, introduction to basic gate, that is AND OR and NOT, then implementation of OR and NOT gate using diodes and transistor, then De Morgan's theorem, and NAND and NOR gate as usual gate. So this will be covered up in this video. You can see this is the total syllabus. In lecture 1 we cover up the integrated circuit. In lecture 2 we cover up the number system, and this is lecture number 3. We want to discuss this portion, that is the difference from this one to universal gate. So we want to cover up to this one in this video. This is lecture number 1, this is lecture number 2, and this will wants to cover up in the lecture number 3. In the upcoming lecture, we will be cover up this portion also. This is the total syllabus of this paper in semester 6 BSc Honors, Calcutta University. So at the first, we just know about the difference between analog circuit and the digital circuit. Analog circuit means where the signal are continuous. The upper on the continuous variable signal. Signal is continuous. But in digital circuit, the signal is not continuous. It is state function, only two state function, that is the discrete value 0 and 1. Okay. And in analog circuit, its efficiency and precision is quite difficult to design analog circuit. Since this is precise and the efficient, that's why analog circuits require more difficult circuit compared to digital. In digital there is only two state 0 and 1, that's why it is relatively low difficult. Okay, next is when interacting with the physical world, analog circuit can directly accept the signal from the outside. Since there is no conversation required in analog circuit, that's why in physical world, so analog circuit can directly accept the signal. Whereas in digital circuit, the signal converted into the 0-1 binary system, that is 0-1 digital signal, that's why we require a conversion. Okay. So in the analog circuit, there is no data conversion, no conversation, so no loss of information. But in digital circuit requires data conversion, signal converted into the binary. So there is a loss of information. Next is precision and accuracy is not criteria, then analog is okay. But when precision and accuracy is not required, then inactive. But when precision and accuracy is required, then analog circuit will be expensive because of the components. But in digital, this is low. And in the terms of range, in analog the value will be 0 to infinite, but in digital value will be 0 to 1. And in analog there is affected by noise, distortion, etc, etc. You can see this is the distortion, but in the digital there will be no such effect. You can see this is the analog signal, analog system we was used before, but in the recent time we use the digital circuit like that. Okay. This is the music system, this is the old music system, and this is the calling system, communication calling system. This is the communication calling system in digital. So these are the basic difference between the analog circuit and the digital circuit. Next topic is the introduction to switching algebra. Switching algebra is nothing but the Boolean algebra. Okay, this is also known as the Boolean algebra. Okay, in Boolean algebra there is three operation: AND, and OR, that is the binary operation, and another one is the unary operation, that is the NOT. So basic three operation, and OR and NOT. AND means the product denoted by dot or the symbol. NOR OR means sum denoted by plus or this symbol, and NOT means complement denoted by this symbol. These are the three basic operation in this Boolean algebra. Okay, so for example, you can see there is theorem is known as this Huntington postulates. This theorem says that a plus a is a plus 1 is 1. Okay, these are the Boolean algebra. A plus 0 is a into 1 is a into 0 is 0, like that. A complement is a. Okay, these are the switching sorry, switching algebra or the Boolean algebra, right? Next topic is the Huntington's postulate. These are the 6 postulate. You know all these things in the other terms, just written here like that. Postulates 1, for all elements x and y in the set S, x plus y is the element of S. For any set S, if x and y are the two elements, then their sum and the product also are the element in this set. Postulate number 1. Postulate number 2, there is exist a constant 0 such that if you x plus 0 is x, write down here 0 plus a plus 0 is a, like that. This is 0 axiom, and x into 1 is x. This is unit axiom. Postulate number 3, that is the commutative property x plus y equal to y plus x, or x into y equal to y into x. Next postulate is known as the distributive property, that is x into y plus z is nothing but x into y plus x into z. And then x plus y into z is x plus z into y plus z. This is the distributive property. Next thing is inverse property, that is x plus x bar is 1, x into x bar is 0. You can prove all these things if you put this value of x is the two value, one is 0, another one is 1, then you can easily prove the all these postulates. Okay, because in digital circuit there are only two value, that is 0 and 1, binary value, that is 0 and 1. That's why so if you put this value of x in terms of 0, suppose this is 0 and this is 0 bar, 0 bar is 1, so 0 plus 1 is 1. And if you take this is 1, so 1, and this is 1 bar, that is 0, 1 plus 0 also 1. Okay, so this postulate number 6, there exist at least two distinct elements in the set S. So at least there is two distinct elements in set A, that is 0 and 1. So these are the 6 postulates. You need to remember these postulates. Okay. Next concept is the combinational logic and sequential logic. What do you mean by combinational logic and what do you mean by sequential logic? In a logic circuit, when the output depends only on these instantaneous inputs, when the output of the circuits depends only on the instantaneous value of the input, then this circuit known as the combinational logic circuit. Clear? A combinational logic circuit is one whose output slowly depend on its current input. But if the output depend its current input as well as the previous output, that is the memory, then this is called sequential logic circuit. You can see in this syllabus this is the sequential circuit. Up to that, this is the combinational logic circuit, that is the output depends only on the instantaneous input, but after that one their output depends on instantaneous value of input as well as the previous output. So these are the sorry, combinational logic and sequential logic. Basic thing, you can see here there is no memory is required in this, but in this memory is required. So in sequential circuit, there is a combinational circuit plus memory. This total is known as the sequential circuit. For example, combinational circuit is half adder, full adder, multiplexer. Sequential circuit is flip-flop, counter, register, etc. Next things, truth table. Truth table has the representation of this output in terms of true or false. Okay. Suppose this OR operation, this is two entity x and y. So this will be combination of this four combination: true, 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 false, false, true, false, false. So the operation for OR, true, true is true, true, false, true, true, false, false, true, true, false, false, false. And operation, product, not operation, like that. You can remember that is true here can be taken as the 1, false can be taken as the 0. That is the positive binary system or positive Boolean algebra. If you taken true as a 0 and false as a 1, this is negative binary system, like that. Okay. So these are the truth table from which we can get the information about the output of this circuit. Next thing is the introduction to the basic function and or and not. So AND gate. AND gate is nothing but the gate in which the output is high when all input is high. High means 1. So this is the circuit symbol of AND gate AB. It is input is 2 or more than 2. There can be 3, 4, 5 inputs, no problem. So for 2 input, this will be A into B. So the truth table will be like that: 0, 0, 0, 1, 1, 0, 1, 1. So product of 0, 0 is 0, product of 0, 1 is 0, 1, 0 product is 0, 1, 1 product is 1. So when all the inputs is 1, output is 1. When all the input is high, output is high. In case of 3 inputs, you can see when all the 3 input is 1, then only the output is 1, otherwise all is 0. This is the AND gate. OR gate, output is high when at least one input is high. When at least one input is high, then output is 1 or high. These are the circuit symbol. The number of input can be minimum 2, maximum infinite. 2 to n number of input can be in OR gate. For 2 input in truth table will be like that. That is 0, 0, 0, 1, 1, 0, 1, 1. For 0 plus 0, this is 0, 0 plus 1, 1, 1, like that. So at least one input gives you output 1. In case of 3 input, you can see this is all is 1 because there is minimum 1 are present, all these inputs, right? Next things is that NOT gate. NOT gate is nothing but the complement of inputs. That is, if you apply A here, you will be get A bar. Okay. For your kind information, in additional, I just say you the buffer gate. Buffer gates not written in your syllabus. For your information, I just write down. This is the buffer gate. Okay. So if you apply A here, okay. So that gates actually change the input impedance, output impedance, like that. Input and output will be the same with the impedance variable. Okay, so this is known as the buffer gate. NOT gate and buffer gate both are the made by the transistor. We will see in the upcoming slide. Okay, it's truth table like that. Input, this is output. In input, this is A. In output, this is also A. So input is 0, output 0, input 1, output 1. Okay. So this will be the buffer gate. Right. Another note is that in gate gate is nothing but the instrument or electronic device which allow the output, or its output depends on the instantaneous input. What is the function of a gate? You know, gate is the gate which allow to entry the particular inputs or its man within this room. Okay, who's have some keys of this room, then this gate is allowed, like that. Okay, so gate is mainly three types: primary gate, universal gate, exclusive gate. Primary gates are three primary gates: AND gate, OR gate, NOT gate. These are known as the primary gates. NAND gate and NOR gate is known as the universal gate. We will be learn why these are called the universal gate in the upcoming slide. And there are two gates, that is exclusive gate, OR gate and XNOR gate. Now comes into the implementation of OR gate, AND gate, NOT gate using diodes and transistor. At the first, we prepare or make the OR gate using diode. There are two diodes and these are the applied voltage. This is the inputs. High voltage taken as 1 and low voltage taken as 0, and there is a resistor and across there is a voltmeter, that is the point of output. When both are 0, that means when both are connected in negative terminal, then both P are connected negative terminal, that is both the diode are in the reverse bias. Since both are in the reverse bias, no current flow through here. Since there is no current flow, the output will be 0. So where two inputs 0, output is 0. In the next case, when A input 0 but B input 1, that is in forward bias, then the current flow through this diode and is flow up through this resistor and will be obtain the output. So when B is 1, output also 1. When A is 1, then the current flow through this diode and this resistor will be obtain the output voltage at y. Okay, so this is case number 3. In the case number 4, when both are in forward bias, the current flow through this resistor, the output will be like that. So this is the total output. You can see this is the same as we written previously of the truth table. So this is the OR gate circuit using diode. And not AND gate circuit using diode will be like that. These resistors is like that and this diode are inverted as compared to the OR gate. Okay, now case 1, when both are in the 0 means are negative. Here you can see this is the N side of the diode. These are connected in negative means these are the forward bias. Then what happened? This current flow through this one and through this diode. No current flow through this high resistive voltmeter, because in voltmeter the resistance will be very high, but these two are forward bias, so current passes through this one. So circuit completed like that. This current flow this one and passing through diode 1 and diode 2 when both are in 0. Both 0 means these are in the forward bias. The current flow through this RL and passing through D1 and D2. No current flow through this voltmeter. That's why we will be obtain the 0 output at this point. That's why when A0, B0, Y is 0 in this circuit. When A0, B1, A0 means this is forward bias. So again this current flow through this D1. So no current in Y. No voltage in Y. Similarly for A1, B0, this forward bias gives also current flowing through this one. But when both are 1, that is both are the reverse bias, so no current flow through this diode, then the current flow through this voltmeter and will obtain the output voltage. So this is the AND gate. You can see when A0, B0, this is 0, A0, B1, this is 0, A1, B0, this is also 0, but when A1, B1, this is 1. So this is the AND gate using diode. Next thing is the NOT gate using transistor. You can see, you know, this is a NPN transistor. This is a NPN transistor. NPN transistor. This arrow gives you the information about this transistor type. Where this is 0. This is 0 means negative. So P side negative. This is positive. So this is reverse bias. Since this is reverse bias, when this is 0, that is the case 1. Since this is reverse bias, no current flow through this one. So this current must be flow through this voltmeter and will be obtain the output. will be obtain the output. But in case when this is 1, this is forward bias, then the current must be flow through the transistor, because this is a low resistive path, because voltmeter have high resistance, so there is be no voltage drop, voltage across this output. Okay. In buffers diode, if you want to say about the buffer gates, diodes means gates, the circuit will be similar to this one. Only difference is that the output point. Only difference is that the output point, this one, okay, is like that, 1 0, and this is 5 volt. Okay, so when this is 0, this is no output. When this is 1, this current flow and will be output. Okay, so this is the buffer gate. So I think clear about these three gates using diode and transistor. Next thing is the De Morgan theorem. This is very important theorem in this digital circuit. That is the, if you take the complement of the product of all terms, then this is equal to the sum of the complement of each term. That is, if you product these terms and then complement, here the complement then sum. Okay, product then complement, complement then sum. So opposite this one, that is the sum then complement, this gives you complement then product. Okay. So here they written the complement of the sum of all term. The complement of sum of all term is equal to the product of the complement of each term. Product of the complement of each term. So this is the De Morgan's theorem. Next comes into the NAND and NOR gate as the universal gates. NAND and NOR gates as universal gates. NAND gate. NAND gate means NOT gate followed by AND gate. NAND gate followed by AND gate. That is the AND gate and then NOT gate. That's why this is called NAND gate. In combination, the circuit symbol will be like that. Okay. So AND gate is product, then they are complement for the NOT gate. Okay. NOR gate is the NOT gate followed by OR gate. So OR gate, then NOT gate. In combination, this will be the circuit. Okay. In output, you can see if you this 0 0, so this 0 into 0 is 0, complement 1. 1 0 0 complement 1. 1 0 0 complement 1. 1 1 1 complement 0. Similar to this one, this is a sum and the complement. 0 plus 0 is 0, complement 1. 0 plus 1 is 1, complement 0. 1 plus 0 is 1, complement 0. 1 plus 1 1, complement 0. Okay. These two gates known as universal gate because using NAND gate or NOR gate you can make the primary gates, that is the AND gate, OR gate, NOT gate. So these primary gates, that is the AND gate, OR gate and NOT gate, can be prepared or make using the NAND gate or NOR gate only. That's why these are the called universal gate. How? Just see this slide. This is the NOT gate using NAND gate. How these two are connected? So this is A and A. So this is A into A bar, and you know A into A is A. So this is gives you A bar. AND gate using NAND gate is like that. That is A B. So this is AB bar, and if you take again complement, so complement is this one. So this is AND gate. And this is OR gate A, this is A bar, this is B bar. If you take here A bar, B bar product, so by De Morgan theorem, this is A bars bar plus B bars bar, that is A plus B. Similarly, NOR gate also make NOT gate, OR gate, AND gate like that. Okay, so this is A plus A, that is A. This is A plus B bar, and bar is A plus B, and this is AB. So using NAND gate or NOR gate, you will be obtain the three primary gates: AND gate, OR gate, NOT gate. That's why the NAND gate or NOR gate is known as the universal gate. I think clear. If there is any doubt during this class, you must comment in the comment box. This is all about me. And this is my contact detail. You can connect me with this Telegram channel, and this is my YouTube channel details. Go to this channel, you will be get different physics related video, some mathematics. Like this session. If you learn something from this session, share this video to your friends so that he or she also get benefit from the video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming video. So take care. We'll meet you in the next video as soon as possible. Thank you.